So this is my project of data acquisition and instrumentation course, and the final project of mine is name is the design and implementation of industrial water controlling management system by using PID, sensor, Arduino, and Servo Motor. So in this project, basically, I developed two systems for the operators, like water control by manual and auto switch. So if anyone want to use the auto switch, then all of the systems will be taken care by the PID here. And if anyone choose the water control by manually, then he has to do it all of the things by manually. So this pipeline is representing the water coming out from the big reservoir in that way, and and here it is our water tank. Here the water will be storage, and the one ISNs will be connected mounted on over the water tank. It will help us to detect the water level, and then will send to the PID, and then PID will take the decision. Okay, and this is the water control valve. It is operated by the servo motor, and the water will be drained out in that system. Servo motor will be whether it will be opened or full closed depends on the how much water we want to have in the water tank. And this is our set point. So right now our set point is 20. This yellow color is representing how much actually emptiness we want to have in the water tank. So don't confuse it. So it is not the quantity of water color, it is the actually emptiness of the water. And this ash color representing the how much quantity of water we want to have. This is our expectation. So right now we can change it 20, and let's see. So if we make it 20, that means we want to 20% emptiness we want to have in the water tank, and that means our water will be 80%, should be 80% in the water tank. So we will see what will happen if the quantity of water more than 80% or below 80%. What actually how the PID will take the decision. So and I also want to introduce with them like this indicator number of servos, number servo, ISM unlock pin, DIO pin. This number of servo representing the as I'm using in the one servo motor. So I can show you in my hardware. So this is the servo motor and this is the IR sensor. So this yellow wire is representing the signal. So same as also in the servo motor, we can see the yellow wire is connected with the DIO pin 8, and this one is connected with the analog pin 0 of the Arduino. And I actually supplied the power from the Arduino like 5 volt and grounded it the breadboard and connected with them. So basically these ISNs will be mounted on over the water tank. So right now if we don't have any water, so we can measure it by our hand. Keep my hand under the IR sensor, and then we'll see if it is measuring or not. So so right now what I said that we want to get 80% of water in the water tank. Okay, let's see. So if I ran it and without my hand, as it is already over the table, so let's see. Yeah, so right now we can see that the quantity of water is below than 80%. Okay, so what will happen? As we want to get 80%, but it is below than 80%, that means we have shortage of water. It means that the water control valve should be closed. It should be closed. It is try to open a bit because it is going to be near 80%. So when it reach the 80%, it is uh, try to uh, try to open a bit, little bit. So immediately actually all of the decision is taken by the PID. So then see if we keep our hand above the IR sensor, what will be happen if it is going to be quantity of water more than 80%. We can see from here. So right now it is below than 80%. Okay. So we can see that right now quantity of water is more than 90%. You can see here 90%. Okay. So what will happen? Like you as you are more we have more water that our presentation I mean expectation, then our valve will open, right? Our valve should be open, so control valve should be open. That's why it now 100. And we can see here the servo motor. You can see the servo motor angle 100. The servo motor will be operated by the water control valve. So whatever the water control valve, servo motor will be showing like that. So What will happen if you just keep the water, if it is then you can see it's rotating. The water control valve is rotating and try to maintain the set point. Okay, so see, so this water tank graph we can see from here is the waveform chart, and here you can see this water tank curve is trying to catch the set point, try to remain as much as near to set point so that it can maintain the what we are doing. So same things also happens if we increase our if we okay if we decrease a bit little bit like 10 points, so we can see make it 10 point, make it 10%. So that means uh, we want to get 10% of emptiness, and we want to have 19% of the water tank in the here. Okay, but right now how much quantity of water we have? 74, but we want to need how much, like 90%. So already we are shortage of water, that's why water control valve is fully closed. Again we can see if we okay, so right now if it is going then 91, see if it is going then 91, then it's try to bit open. Yeah, so in that way it's working, our project is working. So I actually tried to develop the front panel as much as easy for the operator so that anyone can understand. If anyone doesn't have any engineering knowledge, he can also see, if he sees on our front panel, he can easily understand what's going on, what's up to he has to do here. So that's our project basically.